Over the years, I've got the following question a number of times from a number of students. And the question is, in solving a problem involving falling bodies, or in solving a problem of projectile motion, is the upwards direction positive, or is the downwards direction positive? Well, the answer to that question is that the choice of upwards or downwards of positive is entirely up to you. It's not up to me. You make that choice when you solve that problem. You know, if you're a left brain type, you know, you're analytical, you're logical, you might always want to pick upwards to be the positive direction. If you're a right brain type, you're imaginative, artistic, maybe you want to pick positive or negative depending on just what you feel in that moment, your emotions in that moment. Both those are perfectly okay with me. What's important is that once you make that choice of up being positive or down being positive, that you stick with that choice of up or down being positive throughout your calculation. When you're working with displacements or velocities or accelerations, all those displacements, velocities, accelerations have to be consistent with your choice. So let's see how that works with a problem. In this question, I walked to the top. No, I didn't. In this question, I took the elevator to the top of Patterson office chair, and I dropped an egg from the rooftop to the floor below, to the ground below. So that's a 50-meter drop. And we're going to calculate the length of time it takes the egg to fall that 50 meters. And we're going to do it with the two possible choices here of either upwards being positive. So let me put up is positive. It's my shorthand for positive over here on the left. And with the other choice that down is positive. That alternative choice, let's stick that on the right. And let's solve the problem of the time both ways. So starting on the left-hand side with up being positive, I'm going to draw the falling egg. And I'm going to annotate the picture with the information I know. Let's say it starts from the roof. We'll call that height 0. And then it falls to the ground 50 meters below. That's going to be a displacement of minus 50 meters because it's in the downwards direction and upwards is positive. The egg starts with initial velocity 0 and it accelerates downwards. And so that acceleration is also going to be negative because upwards is the positive direction. And so that's the information that we know in the problem. And we've got to figure out the time taken. Well, at this point, I would be thinking about my kinematical equations or my equations of motion. And the one that works best for this problem is this following equation that relates the initial and final positions to the initial speed and the acceleration of the object. It's handy because this term for the dropped object vanishes, the one involving the initial velocity vanishes, and we can simply rearrange this equation by multiplying through by 2, dividing by the acceleration, and taking the square root to get the following equation for the time. In the numerator here is 2 times the displacement, y minus y naught. And in the denominator here is the acceleration. And then we just take the square root of that ratio to get the time. So now let's fill in the values the quantities. So the time will be the square root of, in the numerator, 2 times minus 50 meters minus 0 meters, divided by, in the denominator, minus 9.8 meters per second squared. Now, this is interesting because we've got a negative quantity in the numerator that's minus 100 meters, and we got a negative quantity in the denominator that's minus 9.8 meters per second squared. You can't take the square root of a negative quantity, but in this case, we've got a negative quantity over a negative quantity. So overall, that ratio is a positive quantity. It's about 10.2 seconds squared. And the square root of 10.2 seconds squared is about 3.2 seconds. And so that's the time taken. And so that was solving the problem with the choice of upwards being positive. Now let's look at the problem with the choice of downwards being positive. Again, I was doing it, I would draw a picture of the falling egg. I would annotate the picture with the initial location, the rooftop. We'll call that 0. The final location, the ground, now that's positive 50 meters because downwards is positive. I would fill in the initial velocity being 0. The egg was released from rest. The acceleration of the egg, and now that's also positive because downwards is positive and acceleration of gravity is positive. And then I would go on and calculate the time. Now, when I do the calculation of the time, I would use the same kinematical equation or same equation of motion. I won't write it down again. I would rearrange that equation in the same manner as an equation for the time. I won't write that down again. And then I would fill in the various numbers, quantities in my particular problem. So in the numerator, we'd have 2 times the final position, that's now 50 meters, minus the initial position of 0 meters, divided by the acceleration, that's positive 9.8 meters per second squared. And so we need to take the square root of that. Now this is interesting again. We've got positive 100 meters in the numerator, positive 9.8 meters per second squared in the denominator. Both those quantities have changed their sign. The ratio, though, is still positive. So I can still take the square root. And if I take the square root of 10.2, the ratio of these two numbers, I'm going to get my 3.2 seconds again. In both cases, right, we've discovered that the time the egg hits the ground is positive 3.2 seconds later. The egg hits the ground after it was released. Now, in the two calculations, the distance traveled by the egg, or the displacement of the egg, was either negative or positive 50 meters. The acceleration of the egg was either negative or positive 9.8 meters per second squared. But when it came to the calculation of the time, we got the same time, 3.2 seconds later, as it should be. So it didn't matter whether we chose up to be positive or down to be positive. It was up to us to choose up or down to be positive. But once we made that choice, we were consistent with that choice. Any displacement, velocity, acceleration was written down, was expressed to be consistent with that choice of either up being positive or down being positive. So go ahead, use your left brain, use your right brain, pick the up or the down to be positive as you like, but just make sure you're consistent with it for all your displacements, your velocities, and your accelerations.